Module 5 is all about SRE tools and automation. A lot of people find this the most interesting of the different modules, mainly because automation is always interesting in tools. We'll mostly be talking about use cases for automation for SREs, and not so much about specific tools, but we'll talk about different tool categories and how they relate to automation and some other aspects about selecting tools and so on, which is really important. The syllabus for this module, we'll spend a little time about discussing, what is automation, at least in the context of SRE, how you might think about automating things from a conceptual point of view. The hierarchy of automation types is, again, a way of introducing and adopting evolving automation. We'll talk a little bit about automation for security, which is kind of a crash course on DevSecOps in particular. A little bit about tools, some other things about deployments and automation. We'll touch on other topics that are related to automation, AI ops, using AI, generative AI, and machine learning for operations tasks, value stream management platforms, platform engineering, and generative AI. So there's a lot covered in this module. It's the largest module in the whole course. And there's also a very long video. So the video is called The Ironies of Automation. It's a particularly fun video by Microsoft. We probably don't have time to play all of it during class, but I'll play some of it, and it's up to you to watch the rest of it offline if you want to. There's a case story by Standard Chartered Bank, discussion about greatest hits. I'll share at least one or two of my greatest hits examples of automation. And how do you determine, what is a good amount of automation for your situation? You'll have to determine that ultimately. The general idea is there's almost an infinite number of things you could automate. So what are you actually going to automate? How do you prioritize that? Okay, so automation, defining automation. Think about that before you flip the slides. What do you think of when you think of automation? What's the difference, for example, between automation and orchestration? Automation, you could say, is executing tasks without human intervention, whereas orchestration is more about setting up environments so that you can then run automated tasks. So that's in the IT world, that's a distinction. Automation is valuable from a lot of different points of view. One of the most critical benefits is that automation gives you consistency. If you have some automated script or some automated tool, most likely it's going to execute consistently each time. Whereas if it was a human, maybe you go off script a little bit and you get different results, or you get a little bit inconsistency between one run and the next. Whereas if it's automated, it'll make it more consistent. Something that if automation is done well, then you can use it itself as a tool on which to build further automations. You can think of it as like a tech stack where one automation tool can be used by another one, for example. So you can extend automation. That's kind of a nice thing about automation. Probably what most people are looking for out of automation is to accelerate the time to do things. Usually if a script is automated or a task is automated, it's going to run faster than when the human is involved typing out commands and so on. There's fewer wait states, but more importantly, the automation can run even if there's a human is not available, maybe during the night and so on. So overall, things can happen a lot faster if you automate. It gives you time savings. The example I just gave, rather than having to have a person queued up to run a task, you could have the same task run again and again by automation, even in parallel. If you have only one person to run the task, it's going to be limited. But if you have to run it many times, with automation, you can run those scripts in parallel and save a lot of time. Really, the point is that automation is a force multiplier. It allows you to get a lot more done with a given amount of resource. There's an interesting comment here, not a panacea. You're going to hear that in this module a little more. There are ways that automation can be bad or at least misguided. If you automate the wrong process, for example, or if you don't do a good job of engineering a good automation solution, it can actually cause problems if automation gets out of control, for example, or if it maybe you lose track of what it's doing and it gives you odd results that you can't interpret. So be careful about how you engineer automation, but well-engineered automation is in fact going to give you back a lot of time savings and these other benefits. Automation doesn't happen by itself. It requires a number of things. First and foremost, as SREs, you're really concerned about engineering discipline. The first thing you want to do is clearly understand what it is you're trying to do. Most of the time in the SRE world, automation has to do with reducing or eliminating toil, making something easier to do or less manual. It could also have something to do with meeting or improving SLOs, SLIs. There's another good examples of automation there. You also need tools. You don't usually start automation from scratch. You first of all look around for some monitoring tools or some automation tools. Don't rebuild everything from the ground up. So searching for the right tools to start with for any particular automation project is something that's required. Effort, it doesn't happen by itself. Automation is going to require design, implementation, testing, deployment. All of the things that make up an application, you're going to have to expend some effort to do. Having measurable outcomes. This is something that often I find organizations forget to do, is to put in place some measures of the automation itself to show and validate that it's working. So again, automation helps with multiplying your capabilities, but be careful. It can be not a panacea if you don't do it well. Okay, we're going to do an activity. You might want to stop the video and think about what are the, at least one or two examples of automation projects either you were responsible for or been involved in that had a huge benefit, a large payback. I'll give you one example of my own. We were asked to try to reduce the amount of time it takes to do regression testing. This was back when I worked at Bell Northern Research. We had big communication systems. The main system had 25,000 test cases. It would take 2 weeks to sequence all of those tests, to gather all the results, even without analyzing the results, just to execute the tests. Even though many of the tests were automated, the entire test suite did require some orchestration before they could run the individual tests and so on. It took basically 2 weeks to run the full 25,000 tests. So the goal was to get it down to being able to run the entire test suite over a weekend, in other words, 48 hours. That took us about a month and a half, a team, to re-engineer the 25,000 test suite so that it could run unattended all the way from beginning through to the end. When it was done, though, we were able to run a full regression for that large system over a weekend when people were maybe taking their weekend for themselves, and we'd get results back by Monday morning, so we didn't have to lose a week or two in just getting the results. It was interesting though, because the result of that project, even though it saved a lot of time, we realized that the next level of concern was it took about 2 weeks to analyze the results of 25,000 test cases. So that was the next project after that, which was another greatest hit, to get the analysis time reduced by automating part of the analysis portion of the of that product, automation product. So there's one automation project led to the other, but it was generally considered a good success because of the amount of time it saved. Think about your own, greatest hit and what made it a greatest hit. How did you know it was a greatest hit? How did you measure the result? Did you measure the result? Things like that. Okay, how do you think about automation? This is an exercise we're going to go through looking at automation. First of all, kind of from left to right from a DevOps delivery pipeline perspective, and then we'll look at it more from an SRE perspective from right to left from a production perspective. So the diagram really represents a kind of a generic CI/CD pipeline. At the beginning, development creates some code change. They go through planning, design, create the code, test in their own environment, develop the tests, prepare the test, develop the test, commit the results if the test passed in development, and check some policies to make sure that the CI processes can accept those commit requests and then run CI. So CI starts after the policies are checked with a merge to merge the code changes together with the trunk branch of the code. The next step is often a scan to see whether you've got code quality problems or vulnerability issues from a security point of view by looking at the static code itself. Then you build and containerize the results of the build. Maybe scan images to see whether there's any code quality or security vulnerabilities in the images that are generated. Then run using the latest build results, run some unit tests in a small environment just to make sure that all of those code units are executing properly. Then prepare a test environment within the CI environment. This is usually a fairly well contained, small, not a full-blown system level test, but a integration level test, or some people call it a smoke test, or some feature level testing. You need a test environment for that. Usually that's more than just the unit test environment. Then deploy the new code to that environment, run some CI tests, the integration tests, monitor the results while that's happening, maybe looking for performance concerns and so on. And if that all works great, then you can run a final policy check, create a release candidate, and put that into an artifact repository as a release candidate. It's certainly not an approved release yet, but it's been validated sufficiently to say, oh, this is a potential release candidate. And that's the beginning of the next phase, which is CD, continuous delivery phase. The CD picks up the release candidate from the artifact repository, prepares test environments for that. And in the CD phase, there may be many different kinds of test environments: API tests, performance tests, regression tests, system tests, acceptance tests. They may be implemented serially or in parallel. So you'll deploy to those environments, run whatever system level and the delivery level tests you have, monitor those results, looking for things like performance degradations. Finally, do a final acceptance test. So prepare the acceptance test environment, run those tests, monitor the results during acceptance testing. This might even be a third party involved in validating the results. Finally, if that all succeeds, you'll do a final policy check to see whether or not you've met the criteria for a release. Now you have a release candidate, which is usually available in the same repository, but marked as not just a release candidate, but actually an approved for deployment of an approved release. That doesn't approve actually deploying, though. That's a separate decision. So you'll go into the next phase to determine whether or not you really are going to deploy that approved for release code. And the deployment phase, you'll prepare the production environments, execute whatever your deployment strategies are. Could be blue, green, canary, feature flag deployments we talked about earlier. Execute those deployment strategies, whatever they are, and get the code into production. So this is, again, kind of a DevOps view of the world. This is a process value stream. It's also a CI/CD pipeline with tool chains, many different kinds of tools involved to make this all happen. An ideal situation, if somebody checks in, a really high quality code change, the entire set of processes will run from beginning all the way to the end with no human intervention. It's completely automated. If there are problems at different stages, then those things will get flagged and be determined whether or not you stop, the pipeline to fix something or just carry on and report the problem depending on the severity and so on. So that's the DevOps view of the world.